The new chapter for the session is chapter number 6, which is lines and angles. As we have discussed in the previous chapter about Euclid's contribution to geometry, we have come across various axioms, postulates, and many things connected with lines. So those properties of lines which you have studied in Euclid's contribution is what we're going to extend in learning the connection between lines and angles and various further properties connected with lines and angles. As we have discussed that a line is a unique line which passes through two distinct points, now comes how an angle is connected with the line, is what we are going to discuss in today's session. The lines connected with angles. As we all know that angle is part of two lines, we know what an angle is. So let's see how we connect an angle with the straight line. Imagine I have two lines which are intersecting, the line L1 and the line L2 intersecting at this point. Now my question here is, what is an angle? How many possible angles are existing when these two lines L1 and L2 are intersecting at a point P? I find that there is an angle out here, there is an angle out here, there is an angle out here, and there is an angle out here. So totally there are four angles, 1, 2, 3 and 4 is how I understand the lines intersecting to form angles. There are angles out here which are formed by the two lines intersecting. Let's see the continued properties connected with lines and angles as introduction, continued with the session. Now that we have learned about the introduction of lines and angles, there are some basic terms in the topic which we need to understand before we get into the concept of lines and angles. The basic understanding of the basic terms. So let's see what are the basic terms as used in the topic lines and angles. Initially with the basic terms as used here. Now as that we are defining a line or an angle which is derived from a line, the source of an angle is a line, is how I understand. Therefore, it is very important that we understand the different forms of line representations. Say for example, I have a line which is this, with the endpoints A and B. Then this is called line segment AB. I call this as line segment AB, is how I understand this. Next, say I have a point A, but I don't have the end on the right, or I have point B and I don't have an end on the left, or I have point C, or I have none of the points in between, but it doesn't end on the right and left. These kind of lines which do not end on the either side or on the both sides. Here it doesn't end on the right, here it doesn't end on the left, and here the line doesn't end on either side. Such lines are called rays. I call them rays. A light ray which passes, imagine I take a torch and pass a light ray, it never ends, it goes on and on. So we call this as a ray. The right ray, the left ray, the two end ray is how we define the subterms. So it's very important that we understand the line segment AB and the rays AB before we understand the line AB. Line AB is a line which can be a line segment or a terminated ray on one side or non-terminated on either side. This is how we understand the basic terms which are essential in connecting lines with angles. Now that we have seen some basic terms essential for understanding lines connected with angles, it's also important to understand some extended basic properties like the collinear points or the non-collinear points on the line. So what are collinear and non-collinear points is what we're going to discuss in this session. Collinear points. When do we say collinear? When they are linear to each other. So when are the points linear? If all the points lie on the line, they are collinear. If all the points do not lie on the line, they are not collinear. It's very simple. The word collinear itself says they are linear, therefore we have collinear implies all points must lie on a line. Then only we say the points are collinear. Say for example, I have a line, or this is a ray in which I have 3 points P, Q and R. Let's see if they are collinear. Clearly I have the point P on the line L, and I have point Q which is on the line L, and the point R which is on line L. So since PQR lie on line L, therefore they are linear to each other. Therefore PQR are called collinear points on L. The points are collinear if they lie on the line L. They are not collinear if they do not lie on the line L. This is how we understand collinear points connected with lines and angles. Let's see an example of a situation where we have non-collinear points. For example, I have a triangle ABC. I clearly see that if I take this line L, A and C lie on L, but B does not lie. Since A, B, C do not lie on the same line, since A, B, C do not lie on the same line, therefore A, B, C are non-collinear. Is how we understand the non-collinearity of the points. The 3 points must lie on the line L for the 3 points to be collinear. If one of the point does not lie on the line, though the other 2 points lie on the line, all the 3 points are said to be non-collinear. Non-collinear do not lie on the line. Collinear, the points lie on the line L, is what we learn as the learning outcome. Now that we have learnt some basic terms and properties in lines and angles, now comes the essentiality of recognizing the different types of angles involved when two lines intersect. Types of angles is the session about. Types of angles. Now that we have seen two different lines intersecting, we have them intersecting in different ways. Say for example, I have the two rays. In the first case, passing from P, I clearly see that this angle, if I represent with theta, is less than 90. So any angle which is less than 90 is called acute angle. Say for example, I take this as x. So if the angle is less than 90 and greater than 0, then I call this angle as acute angle, is how we understand the formula number 1. Secondly, if I take a line which is exactly perpendicular to the other line, so ray 1 and ray 2 are perpendicular, then this x equals 90, then x is called right angle. If the angle is 90, that angle is called right angle. If the angle is less than 90, it is called acute angle, and if the angle is greater than 90 is what we are going to discuss further. An angle greater than 90 degrees. Let's investigate. If this is x, then any angle which is greater than 90 and less than 180, an angle which lies between 90 and 180 is called an obtuse angle. Is how we see the three different cases of an angle. Less than 90, acute, equal to 90, right angle or perpendicular angle, and between 90 and 180, it's obtuse angle. So for these two lines or the rays, the angle is obtuse because it is more than 90 and of course less than 180. These two lines make an angle of 90 degrees because they are exactly perpendicular to each other. These two rays are obviously less than 90 degrees and therefore such angles are called acute angles. Types of angles connected with lines and angles: acute angle, right angle, and obtuse angle. Now that we have discussed about the types of angles, acute, right angle, and obtuse angle, now let's take two special cases which are very important. What if the angle is more than 180 degrees? Is how we investigate two special cases. Types of angles taken as special cases. Now in this case, as we have seen that an angle less than 90 is acute, when x is 90 it's right angle, more than 90 and less than 180 is obtuse. Now comes the investigation on what happens if the angle is 180 or more than 180 as special cases for types of angles. Let me take the first case of 180 degrees. Say for example, I have the two rays which make an angle of 180 degrees. So when the angle is 180, then that angle is called straight line angle. So such a line is called straight line angle is how we define for 180 degrees. Similarly, what happens if the angle is more than 180? Say for example, I have an angle this which is more than 180. So have this to be between 180 and 360. So here I have an angle more than 180 and less than one full circle. So such a case, X is called a reflex angle. That's how we understand the straight line angle and reflex angle which are more than 180 and equal to 180. X equals 180 degrees implies that angle is called straight line angle as made by the two rays. X greater than 180 and less than 360 called reflex angle. Straight line angle and reflex angle has the special cases of the types of angles. What if the angle is 360? If suppose, let me end with the last angle which is 360 degrees. If the angle is 360 degrees, then I have a full circle which is formed. And hence this angle which is one full 360 degrees is called one full circle angle. X is called one full circle angle. Is how we derive the different types of angles connected with lines and angles. Types of angles in special cases. Complementary angles is what we are going to discuss in the session. What are complementary angles? Now that we have discussed about the different types of angles, now let's enter into understanding the types of angles extended with the definition complementary angles. What are complementary angles? The angles whose sum is 90 degrees is called complementary angles. That is, when I take the angles x and y, if x plus y equals 90 degrees, then we say the angles x and y are complementary angles. Let's see the definition more briefly. Imagine I have two lines which are perpendicular to each other. There are two lines out here which are perpendicular to each other. Imagine there's an angle between them. There's another line which makes an angle x and y with the given perpendicular lines. Now, since we know that the whole line is perpendicular, therefore, my each angle being x and y, the sum would be 90. Therefore, clearly I can see from this diagram that angle x plus angle y equals 90 degrees. And when sum of two angles is 90, then we call x and y to be complementary angles. Two angles are said to be complementary if the sum of those two angles is equal to right angle, which is 90 degrees, as can be seen with this example problem. Complementary angles. Now next is about supplementary angles. Let's see what do we mean by supplementary angles. As with the similar definition of complementary angles, now comes defining the supplementary angles. Supplementary angles. If the sum of two angles is 180 degrees, then we say the two angles are supplementary angles. So let's see the definition more briefly. Imagine I take a straight line. Let me say there's another line which cuts this line at some angle. Therefore, I have this line which cuts these two angles, say with angle X, and this is angle Y. Now clearly when I see this part being angle X and this part being angle Y, clearly angle X is acute and angle Y is obtuse, because this is less than 90 and this is more than 90. As can be seen with an imaginary perpendicular line, this will be more than 90, less than 90. X is acute, Y is obtuse. Also, when I observe this, I know that angle in a straight line is always 180 degrees, is what we know as the property. So since the angle in a straight line is 180, this whole angle must be 180 degrees. And also, when I connect this with this X and Y, I see that angle X plus angle Y makes the whole angle of the straight line. Therefore, as seen from the diagram, X plus Y is 180, and we have the property that if the sum of the angles is equal to 180 degrees, then the two angles are called supplementary angles. If this equals this, implies X and Y are called supplementary angles. Supplementary angles and its definition. So the learning outcome is, if the sum of the angles is 90, the two angles are called complementary angles. If the sum of two angles is 180 degrees, then the two angles are called supplementary angles. Complementary and supplementary angles. Now that we have discussed about supplementary and complementary, it is also very important that we also know some basic angle rules in lines and angles. So let's see some basic rules in angles, how we define the different types of angles existing in geometry. For example, initially I have adjacent angles. What are adjacent angles? The word adjacent means the one besides the other. Therefore, when we take two angles, the rule is that the two angles are said to be adjacent when one is exactly besides the other. For example, let's take an example case. For example, I have two lines out here, where this angle is X and this angle is Y, and this angle is Z, XYZ. Now here, let's see how the adjacent angles can be applied to this. Now clearly I see that X and Y are besides each other. But when I take the pairs X and Z, they are not besides each other. So very clearly I can say X and Y are adjacent angles. Y and Z also are adjacent because they are besides each other, are also adjacent angles. But when I take this angle X and this angle Z, they are not adjacent because clearly they are separated by the angle Y, as can be seen. Therefore, but X and Z are not adjacent angles because they are not side by side is the rule I identify in adjacent angles. Two angles are adjacent if they are besides or side by side. XY adjacent, YZ adjacent, XZ not adjacent is how I understand the adjacent angles in the geometry of the planes. Next is about linear pair of angles. Let's see what are linear pair of angles. As clearly the word itself says, linear pair, what do we mean by linear pair? That means the angles involved in a straight line. The pair of angles involved in a straight line. Linear pair indicates pair of angles involved in a straight line. Let's see how the pair of angles are involved in a straight line. In order for that, I need a straight line. So let's draw a straight line and see. I have a straight line out here represented by L. Then I have another line or a ray which makes an angle. When it intersects the straight line out here, intersects the straight line L out here, it makes two angles, X and Y. So in such case, we clearly see this pair of X and Y to be the linear pair because these two angles together make a straight line. That means for the pair of angles to be linear pair, the sum must be 180, or the sum must be, or the angles must be supplementary angles as learnt in the previous case. Therefore, clearly I see here that X and Y are pair of angles involved in a straight line. Or pair of angles involved in a straight line. Also, if you notice here, we observe that X plus Y equals 180, as can be seen in the linear pair, since L is a straight line. Therefore, I can say X and Y are supplementary or supplementary angles. Therefore, we have X and Y are said to be linear pair if XY are supplementary, is how I make the learning outcome. The condition that X and Y are linear pair of angles is that X and Y must be supplementary. That is, X plus Y must be equal to 180, or it must be in a straight line. This is how we understand the linear pair or supplementary in a straight line. They cannot be supplementary outside the straight line, but on a straight line they must be supplementary, and hence for linear pair they must be on a straight line. X and Y are linear pair of angles when they are involved in a straight line. Angle X and angle Y is how we understand. Now the next type of angles which we're going to discuss in the plane geometry is vertically opposite angles. Let's see what are vertically opposite angles. vertically opposite angles. Let's see the definition through the diagram. Imagine I have two lines which are intersecting in the plane. Say for example, my line L1 and my line L2 intersect at this point. Now let's see how we can define the vertically opposite angles for the case of two lines L1 and L2 intersecting at certain point. So in this, as we know that opposite angles, vertically opposite in the sense, there are two angles which are opposite out here, this, and these two are called vertically opposite angles. Or I take this 1 and 2 and I take here 3 and 4. As can be seen here, these two are vertically opposite angles 1 and 2, and 3 and 4 are the next pair of vertically opposite angles. So here in this diagram we have angle 1 and angle 2 are said to be vertically opposite angles. Similarly, angle 3 and angle 4 are also said to be vertically opposite angles. 1 and 2 and 3 and 4 are said to be vertically opposite angles. So when two lines intersect, at that point of intersection we have four angles formed, and the opposite pairs are said to be vertically opposite angles. In this case, 1 and 2, 3 and 4 are vertically opposite angles. Also, geometrically, we have angle 1 equals angle 2 and angle 3 equals angle 4. So vertically opposite angles are always equal in point of intersection. So here we make a property that vertically opposite angles are always equal. For any lines intersecting, this is universally true. Is said to be universally true. Is how we understand the vertically opposite angles are always equal for any two lines intersecting. Angle 1 equals angle 2, angle 3 equals angle 4. Is how we understand the learning outcome and the definition of vertically opposite angles. Now next, let's see, now that we have discussed about the different types of angles defined in the lines, now let's enter into taking the condition of the possible lines, two lines, whether they intersect or do not intersect, are they parallel, are they coincident, etc. So let's see different cases of two lines intersecting or non-intersecting. So here I have types of lines. So when I take two lines, there are different possible ways in which I can understand the geometry of the lines. Initially, let me come with the first case. When I have two lines, the possibility is that this line L1 and this line L2 intersect at a point P. This is the first case where the two lines intersect at the point P. When I take the second case, there is the possibility that the two lines are parallel to each other. So there is a possibility that the two lines either cross each other or do not cross but exactly go on a railway track, never meet each other. So we have the second case, which is of this form. The third case is when the two lines L1 and L2, the line L1 and L2 lie on each other. They overlap, or one line lies on the other, or they are coincident. So let's see the three cases where the lines intersect at a point or parallel to each other, they are coincident. So here such lines are called intersecting lines. In such a case, these kind of lines are called intersecting lines, and when they are going exactly at equal distances on the railway track, then we say such lines are parallel lines. And in this case, when the two lines exactly overlap on each other, making us look like as if there is only one line, but L1 and L2 are exactly on each other, then in that case, these kind of lines are called coincident lines. Is how we understand the different types of lines existing in the plane geometry. Intersecting lines, parallel lines, coincident lines. Now that we have discussed about the different types of angles and the different types of pairs of lines existing and various other properties connected with lines and angles, now let's see one of the axiom which is important in understanding the lines and angles more better. An axiom with its own definition. Now here an axiom says, if a ray stands on a line, then the sum of two adjacent angles so formed by the ray with that of the straight line is 180 degrees, is how the property or the axiom says. So let's see this axiom through the diagrammatic representation to understand the concept more easier. So here it says, if a ray stands on a line, so let me take a straight line. Here is the straight line, say L. And imagine I project a light through the torch on this. So a ray of light is made to hit out here. If a ray stands on a line L, this is how it stands in any angle irrespective of 90 degrees. Then if a ray stands on a line, this being the ray, this being the line, the axiom says that the sum of two adjacent angles so formed by the ray, we clearly know that the adjacent angles formed by the ray are this and this. So the sum of two adjacent angles so formed by the ray with that of the straight line will always be 180. So these two adjacent angles always form the sum 180. Obviously, because the ray makes with the straight line being 180, the property says x plus y is this. This is how the axiom states. If a ray stands on a straight line, then the sum of the adjacent angles so formed by the ray with that of the straight line will always be 180 degrees. That is, x and y will be supplementary angles, is how we understand the axiom related with plane geometry. Now that we have discussed about axiom 1, let's see the axiom 2, which relates to the properties of the plane geometry. Axiom 2 and its definition. Axiom 2 states that if the sum of two adjacent angles as made by the ray is 180 degrees, then the two non-common arms which make the respective adjacent angles with the ray must form a line, is how the property says. Let's see axiom number 2. The axiom clearly states if the sum of two adjacent angles as made by the ray. Now it is given that the angles are adjacent. Say for example, I have a ray. Now this ray makes adjacent angles and the sum of adjacent angles is 180 degrees, and then the two non-common arms which make the respective adjacent angles. Say for example, my adjacent angles here are x and y. They are besides each other. Then the angle x which the ray makes, say this is the angle x as made by the first non-common arm. This is the first non-common arm which makes an angle x with this ray. Now there's another angle y which is just adjacent to x and made by the other non-common arm. So let's see the other angle which is made by angle y. So the ray makes an angle y with the next second non-common arm. So the first non-common arm makes an angle x with the ray, and the second non-common arm makes an angle y with the ray. Now the axiom 2 states that in such a case where x and y are adjacent, these two non-common arms must form a straight line. They cannot be bent, they must be straight, or they form a straight line, is how the property states, the axiom number 2. Therefore, first and second non-common arms must form a straight line according to axiom number 2. Therefore, when x and y are adjacent angles as made by the ray with the two non-common arms, first and second, then this ray making an angle x with the first non-common arm and this ray making an angle y with the second non-common arm, and provided x and y are adjacent besides each other, then the axiom number 2 states that the first and second non-common arms must be a straight line. They cannot bend even with a slight angle. They must be forming a straight line. Axiom number 2 and its definition. And as the two axioms which we have discussed in the session, axiom number 1 and axiom number 2 are very much related to the linear pairs. Therefore, the two axioms related to the linear pairs are called linear pair axioms. Just to make a note, the two axioms which we have discussed are called linear pair axioms. Is how we define the axioms and the respective linear properties. Now let's see the property of vertically opposite angles. Now that we have discussed with the axioms on linear pair of angles, let's see a property related to the vertically opposite angles. As we have clearly seen, let's see a theorem which relates to vertically opposite angles. Vertically opposite angles are derived when two lines intersect. So here is line 1 and here is line 2 intersecting at this point. Then we know clearly that pair 1 and 2 are called vertically opposite and pair 3 and 4 are called the other set of vertically opposite angles. Now this theorem says that the vertically opposite angles are always equal, is how the theorem states. Vertically opposite angles are always equal. Let's see how we can come to the conclusion that vertically opposite angles are always equal. Let's come with the first case where if I take this line L1, I clearly see that 1 and 4 are adjacent angles. In line L1, I clearly see angle 1 and angle 4 are adjacent or besides each other. Not only that they are adjacent, but they form a linear pair. Also, one and 4 form a linear pair. They form a linear pair and therefore 1 plus 4 must be equal to 180 degrees. That implies angle 1 plus angle 4 equals 180 degrees is how I get the linear property. Similarly, if I take the line L2, in line L2, angle 3 and angle 4 are clearly, angle 2 and angle 3 are adjacent angles. And as you see, angle 2 and angle 3, they also form a linear pair. Also, angle 2, angle 3 form a linear pair. And therefore, because these two form a linear pair, the sum of angle 2 plus angle 3 must be equal to 180. as the second case, is how we get the linear property. Now, as we see with the first property, angle 1 plus angle 4 is equal to 180. Similarly, when I take angle 1 and 3 from the above diagram, I clearly see that angle 1 plus angle 3 is also equal to 180 degrees, and angle 2 plus angle 4 is also equal to 180 degrees. Because it's a straight line out here and this is a straight line out here. 1 plus 3 is 180, 2 plus 4 is also 180. So here I have four equations: equation 1, equation 2, equation 3 and equation 4. So let's see how we can prove. As I see that equation from 1 and 3, I clearly see that the two equations are same, because the right hand side is 180 and the right hand side is 180. By transitive property, both the left hand sides must be equal. Therefore, from equation 1 and 3, I observe that angle 1 plus angle 4 is equal to angle 1 plus angle 3, because the right hand sides are equal. Therefore, from equation 1, angle 1 plus angle 4 must be equal to angle 1 plus angle 3. Therefore, the two angles being equal can be cancelled on both sides. Therefore, I get angle 4 equals angle 3. Is one property which I proved. Similarly, let me take equation 2 and equation 4 and see what we can conclude. Now, from 2 and 4, also equally I can conclude that from equation 2, angle 2 plus 3 is 180, and from 4, 2 plus 4 is 180. Because the right hand sides are equal, the left hand sides must be equal. Therefore, this on the left hand side must be equal to this on the left hand side. So here, angle 2 plus angle 3 is equal to angle 2 plus angle 4, where the two angles being equal will be cancelled on both sides. Therefore, I get my angle 3 equals angle 4. Of course, here I get the same thing because they are same. So I have my angles here. The one of the pair vertically opposite are equal. Therefore, vertically opposite angles, angle 3 and angle 4 are equal. Vertically opposite angles, angle 3 and angle 4 are equal, is how we conclude the vertically opposite angles. 3 and 4 are equal. What about 1 and 2? Yes, they are, because when angle 3 is equal to angle 4, then angle 1 is 180 minus angle 3 and angle 2 is 180 minus angle 4, where we can prove that angle 1 and angle 2 are also equal. Let's see how we can show the other pair being equal from this. Continued.